Welcome to Demystifying Math. In this lesson, we're going to be finding determinants of 3x3 matrices. Let's remember what the determinant of a 2x2 matrix is. If you have the matrix ABCD, the determinant of that is AD minus BC. As an example, we have the matrix 1, 2, negative 3, negative 4. The determinant of that is 1 times negative 4 minus 2 times negative 3, which gives us 2. We need to use the 2x2 matrices found inside a 3x3 matrix to find the determinant of the 3x3. To get the 2x2 matrices, what we're going to do is eliminate a row and a column. So we're going to start by eliminating the first row and the first column. That gives us a 2x2 matrix that is EFHI. We're going to take the determinant of matrix EFHI and multiply it by the element in position A. A is at the cross of the row and column that we eliminated. Next, we're going to eliminate row 1 and column 2. This gives us another 2x2 matrix, which is DFGI. This will be multiplied by the intersection of the row and column that was eliminated, which is position B. Our third 2x2 matrix is going to be found by eliminating row 1 and column 3. So we have DEGH. And the intersection of the eliminated row and column is C, so we're going to multiply that by C. The only thing that's different is we have sign changes. So when we're keeping the first row steady, we're going to have plus minus plus. So we're going to keep the sign of the first intersection of row and column, change the sign of the B, which is the second situation, and keep the sign of the third one the same. So that would be our formula for finding the determinant of a 3x3 matrix. Let's find this determinant. We're going to first eliminate the first row and the first column. And we're going to multiply the matrix that's left over by the intersection of the row and column eliminated. Next, we're going to eliminate column 2 and row 1. Our intersection is 0. If it was any other number, we would have to change the sign, so I put the negative there just to remind you of that. And our 2x2 matrix that's left over is 3, 0, 2, 3. Next, we're going to eliminate the third column in the first row, and we're left with matrix 3, negative 1, 2, 1, and we're going to multiply that by 5, not changing the sign on that one. Then use our formula for the determinant of 2x2 matrices. So our first matrix, we're going to do AD minus BC, which is negative 1 times 3 minus 0 times 1, and multiply that by 1. And the second one was 0 anyway, so we didn't bother to find that determinant. And then the third one is a 5, so we have 3 times 1 minus negative 1 times 2, and that's going to give us 22. So that's one way to find the determinant of a 3x3 matrix. You could actually hold steady any of the rows or columns and do the same thing, but you need to find 3 2x2 matrices. If you're using the second row, the signs alternate, so it becomes negative, positive, negative. So for this one, we're going to eliminate the first row, first column, and second row. So our intersection is 3, but we're going to change the sign to negative 3. And then we're going to eliminate the second column and the second row, and that intersection's at negative 1, so our resulting matrix is 1, 5, 2, 3. And then eliminating the third column in the second row, we have 0 times 1, 0, 2, 1. And then just evaluate the determinants of the 2x2s and multiply it by those constants. And again, we get 22, so it really doesn't matter which row you had kept steady. But let's do the third row just to show you. In this case, we're going to eliminate the third row in the first column. So our 2 is our intersection. Our resulting matrix is 0, 5, negative 1, 0. Eliminating the third row in the second column, our intersection is at 1, but these signs are positive, negative, positive, so we had to change the sign on that one. Eliminating the third column and the third row, we have 3 times the matrix 1, 0, 3, negative 1. And again, we get the same value for the determinant. You could also keep a column steady while the rows change. So in this case, we're going to keep column 1 steady and choose 3 rows. So we have our intersections at 1, and our matrix is negative 1, 0, 1, 3. And this again, we're going to alternate the signs, so it's positive, negative, positive. So we have the negative of 3 times the resulting matrix 0, 5, 1, 3. And then using our third row, the first column, we have plus 2 times 0, 5, negative 1, 0. And again, we get 22. So you can do it any of those ways, but you really only need to do it one way. So choose the way that you like to do it, or look for things where you have lots of zeros. So you might choose that. Makes it a little bit easier. Doesn't save a lot of time, but it saves some time. Okay, so let's find this determinant. We're going to use the first column in the first row. So our intersection's at 2, and our resulting matrix is 0, negative 1, 2, 4. Remember, with the middle one, you're going to change the sign. So it was negative 3, which is going to become positive 3. And our resulting matrix is 5, 1, negative 1, 4. 5, negative 1, 1, 4. And then our third column and first row gives us an intersection of 1. And we have 5, 0, 1, 2. And our determinant in this case is 77. Okay, thank you for watching Demystifying Math.